Alright guys, welcome to this page of the notes. Let's go ahead and have some fun. Here's what we're going to do. We started off this new chapter talking about inscribed angles and central angles. I know we took sort of a little rabbit path there when we started talking about arcs and measuring the lengths of arcs or the measure of arcs, and we needed to do that in order to move on to what is now known as the inscribed angle theorem, which is an awesome theorem. Here's the way this is going to go. I've written the theorem for you right here. I know it looks like a crazy complicated theorem. I promise you it is not that difficult. Let's talk about it right here. Here's the way the theorem works. What the theorem says is it simply says this: the measure of angle ADB. ADB is the inscribed angle. Here it is right here. This is inscribed angle AADB. What is the measure of that inscribed angle? Why is it an inscribed angle? Simple. Remember our definition for inscribed angle, right? Your job is to learn the vocabulary, right? Point D is on the circle. DA is a chord. DB is a chord. That means that angle D or ADB is an inscribed angle. How do I find the measure of that angle? Well, the formula tells me the measure of that inscribed angle is equal to 1/2 the measure of arc AB. So, this arc right here. If I know the measure of the arc, multiply it by 1/2, and I get the measure of the angle. If I know the measure of the angle, and I want to find the measure of the arc, just multiply the 2 to the other side, 2 times the measure of the angle, you will get the measure of the arc. All right? So what it is it's simply the inscribed angle theorem is a relationship between the inscribed angle and the measure of the arc that is created by that inscribed angle, right? This inscribed angle, when I draw those chords through the circle, it creates an arc on the other side, right? The inscribed angle theorem is the relationship between the measure of the angle and the length or the measure of that arc. And this is the relationship. All right, we're going to use this theorem a ton here in the next couple of problems. You're going to love them. They're great. One other quick thing to point out is simply this. In the event, right, in the case where you have this inscribed angle diameter theorem, we'll use this a little bit as well. Well, not a little bit. It'll show up in the problems we're about to do. It's just simply this, right? Please notice I have an inscribed angle. This guy right here, this is an inscribed angle. How do I know it's an inscribed angle? The vertex is on the circle. The sides of the angle are chords, right? They're chords. But please notice what happens. The end point of the chords is also the diameter of the circle. Look. Let me label these guys. D, A, B. Look. Chord AB. Chord AB is a semicircle. It's 180 degrees, which means chord AB is a diameter. It splits the circle in half, right? Splits the circle in half. Here's what the theorem says. If that's the case, if the endpoints of these two chords, DB and DA, are the diameter of the circle, then the inscribed angle must be 90 degrees. It must be 90 degrees. Now why? Why does that make sense? Let me show you both ways. First, I know that arc BA, or AB, whatever you want to call it, I know that arc BA, I apologize, I forgot my 1/2. Okay, I know that arc BA, thanks to what we talked about earlier in the set of notes, I know that that's 180 degrees. Because you can do this math in your head. Put 180 degrees in there, what's 180 degrees divided by 2? It's 90, it's 90, so the measure of the inscribed angle has to be 90 degrees. Or think of it this way, right? Let's say I know the measure of angle ADB is 90 degrees. Okay, so you're going to plug 90 degrees in right here. You're solving for BA. So if this is 90 and it's equal to 1/2 arc BA, how do I solve for arc BA? Well, since I have division by 2, I have to multiply the 2 to the other side. You can do this in your head. What's 2 times 90? It's 180 degrees. So the measure of arc AB would be 180, right? See how that works? Okay, so the inscribed angle diameter theorem is just simply saying if you have, if the endpoints of that arc are a diameter, then, right, the measure of the arc is 180 degrees and the measure of the inscribed angle has to be 90 degrees. All right, we'll see that show up here in a couple of problems, so let's do one. Here's what we got. Based on the information I have given you in the diagram, let's first go ahead and find the measure of arc DE. Okay, here we go. Let's arc DE. Where's he at? Right here. Here's arc DE right there. There he is. And please notice that arc DE has these two chords, AE and AD. Fantastic, right? These are the two chords that sweep out that arc DE. Well, please notice what I've given you. I have given you the measure of angle EAD. So, we'll use that inscribed angle theorem. Remember, the way the angle theorem works is it says this: the measure of angle EAD is equal to 1/2 the measure of arc DE, right? That is the inscribed angle theorem. It's right up here on your notes. That's the formula. What do I know? Well, I know the measure of the angle. I gave it to you in the diagram. It's 54 degrees. Plug and chug. 54 degrees is equal to 1/2 the measure of arc DE. Simple, simple. Multiply the 2 to the other side and cuckoo ka-choo, you got yourself an answer. So we're going to have 2 times 54 degrees is equal to the measure of arc DE, which means the measure of arc DE is equal to 2 times 54, which is simply 108 degrees. All right, so the measure of arc DE is 108 degrees. Now, we got a lot of things to figure out here. Look at all the stuff I asked you to solve for. So what I'm going to do is I'm going to erase this work that I just did here. I'm going to slide this guy up here so that we've got that answer in case I need it in the future, because I might need it in the future. You may be able to write a little bit smaller than I can. I got to write big enough so that you guys can see. So if you're able to squeeze all of this into this space that I've given you, good for you. I'm going to need to conserve some space. Again, remember we got 108 degrees. All right, fantastic. There's the measure of arc DE. All right, let's keep going. The next thing I ask you to find is I ask you to find the measure of arc BD. Well, look, right? BD. BD. Okay, no problem. Here we go. Let me erase all of this over here. We already found DE. Now we're looking for the measure of arc BD. Well, think about what we just found. We just found that DE was 108 degrees. And look at what they tell me in the problem. They tell me that the measure of arc BE is 18 degrees. The arc addition postulate. You know that the measure of arc BD is going to be equal to the measure of arc BE plus the measure of arc ED. Plug and chug, guys. Probably don't even need a calculator, but feel free to use one just to be sure that you don't make a mistake. You'll simply add 18 to 108, and like me, you'll get 126 degrees. 126. Arc addition postulate. You sum together the measure of the two smaller arcs to get the measure of the larger arc. Again, I'm going to erase, slide this guy up so that I have space to do the rest of my work. That way I'm not squeezing and making it so that you guys can't see what I am doing. Erase, 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 erase. Erase, erase. Erase, erase, erase. Okay, here we go. So we said the measure of arc BD was 126 degrees. Fantastic. We're doing good. Let's keep going. I want you to find the measure of angle. What? It's an angle. I want the measure of angle DAB. Okay, here we go. Let's erase what I got here. Erase, erase, erase. Here's what I'm asking you to find. I want you to find the measure of angle DAB. DAB, I want you to find the measure of that angle right there. Hang on, that looks a little weird. Hang on. Let me try again. There we go. All right, well, I've already done a portion of the work for you. Please notice, I already know this little part of it is 54 degrees. So all I have to do is find that extra little sliver, right, and add them together, the angle addition postulate. Well, how do I find then the measure of that angle, right? What angle am I talking about? This angle right here, BAE, the measure of angle BAE. I need to know the measure of that angle. Well, fortunately, we have our inscribed angle theorem. Here's what you know. From up above, that formula up above, you know the measure of angle BAE is equal to 1/2 the measure of arc BE, right? That's the way the formula works. The measure of the angle is half the measure of the arc that inscribed angle makes. And you know the measure of the angle. It's 18. Guys, this couldn't be any easier. Once again, plug and chug. This is absolutely math you don't even need a calculator for. It's 1/2 times 18 degrees. And sure enough, you get the measure of angle BAE is 9 degrees. Once again, to make sure that I am not squeezing on you, that I'm writing big enough for you to see, I'll erase all of that, and we are on a roll here. Let me go ahead and get rid of all of that and figure out what's the next thing I want you guys to find. Boom. I want you to find the measure of ADE. Here we go. This guy right here. I want to know what is the measure of ADE. Measure of ADE. I want the measure of that angle right there. Fantastic. Hopefully you recognize it. You should see it. If you don't, let me point it out to you. What is this guy right here? Right there. What is that guy? AE. AE. What is that? Yeah, that's a diameter. Well, now we go back to our inscribed angle of a diameter theorem, right? Remember what happens since this arc, right? The arc AE. Right. How big is that arc? Well, since AE is a diameter, that means the arc is 180 degrees. It's a semicircle. It's half the circle, right? We just spent a ton of time talking about this. If arc AE is 180 degrees, what does that mean the measure of the angle has to be? It has to be 90 degrees. It has to be. So because of the inscribed angle of a diameter theorem, the measure of angle ADE is 90 degrees. It's got to be. It's 90 degrees. All right. So that's the way these problems are going to go. We're going to use those two theorems, the inscribed angle theorem and the inscribed angle of a diameter theorem, to help us solve several of these problems, incorporating that geometry and algebra together to help us do it. What I'll do is on the next page of the notes, we'll do another problem together, and I'll meet you guys there.